All right. My name is Luke McConoughey. I'm director of the Computer Security Incident Response Team at Silicon Valley Bank. We deal with hackers, fraudsters, internal shenanigans, the whole 9 yards. It's a lot of fun. Today we're going to chat about who is attacking America, our corporations, really everyone in the world. We've all heard about APT, the Advanced Persistent Threat. Typically, these are nation-state actors targeting a wide variety of interests, both U.S. Hacking other countries, China hacking U.S. and other countries, and the like. And below that, we have organized crime. Crime families, primarily in Europe, sometimes in Africa. You might have received an email from a prince who has a lot of money he wants to share with you. And finally, script kiddies. We call them script kiddies. We'll get a little more into that here in a second. These are broad generalizations. These are the typical attackers that hit us. And the real difference between an APT or a script kiddie is the amount of resources, the amount of knowledge they have to inflict pain on folks like me and my team. The other difference is the amount of operational security. They're OPSEC. APT attackers tend to be very quiet and stealthy, coming into our environment, operating without setting off a lot of sensors. Another characteristic for the organized crime folks tend to be a smash and grab. They want to come in, they want to hit it hard and get out. If you might have noticed over the weekend, there was an ATM ring in Japan that did a multi-million-dollar cash out over the weekend. So they want to get in, they want to get money, they want to get out. Script kiddies, on the other hand, are very noisy. They tend to not know what the attacks that they're doing will do to the sensors on the target, on the victim. So when they look at what they're attacking us for, APT tends to be going after our intellectual property. They tend to have a colonization attack plan where they want to come in, land, and expand within your organization. Very often they'll compromise a host, lay low for a month, and then start activating that asset internally within your environment. And once they're active, they tend to move laterally, very stealthily throughout your organization. The organized crime, those folks, they tend to look for money and money movement. You might have been aware of some of the FBI or DHS advisories recently around business email compromises. They're saying, hey, comptroller, this is the CEO. We are about to do an acquisition. It's hush hush, don't tell anybody. Wire $38 million to this address. And many organizations are falling for it. A more recent one, rather scary this year, is the CEO supposedly is emailing the HR team saying, hey, we need the W-2s for all employees. Go ahead and email that to me. It's scary stuff. But all that information can be used to leverage either money movement or tax fraud and a wide variety of other horseplay against our companies, our employees, and the like. Script kiddies, that's a very loose term. It could be hacktivists. It could be someone who's just firing up a new port scanner that they're trying to check out. It may be somebody well-intentioned. When we have something hit us, we don't know if it's a kid trying to be helpful and say, hey, we found what looks like a security bug, or it's somebody just scanning the internet. If you connect the system to the internet, you'll ultimately get scanned in mere minutes of a wide variety of folks out there. So when we look to defend against APTs or script kiddies or organized crime, we look at the defense in depth model. Hopefully many of you folks are familiar with this. This is the idea of using multiple overlapping controls in your security stack. This is protecting your data, fingerprinting your data, making sure that that data is not leaving the organization, making sure your applications are hardened, integrated with other IT systems, and then your internal networks are partitioned off and isolated from other folks, other assets to ensure that we don't have lateral movement best we can. Of course, protecting your perimeter, for many years, it was all about the firewalls. It was all about protecting the front door. And you can't forget about the physical access to your data center as well. And finally, around that, your policies and procedures, your end user awareness, being aware of the threats coming in is absolutely critical. There's lots of tools at every layer. This is the kill chain. I believe Lockheed Martin popularized this after their hack a few years back. Kill chain talks about how threat actors get into your environment, and what they do after it. First thing they do is reconnaissance or footprinting of your environment. They look for a way in, they look for a weak spot. Then once they have a foothold or a toehold, they look to weaponize that asset and get it into your system or into your environment. From there, they can do further exploitation, installing additional command and control infrastructure within your environment. And finally, they can start either exfiltrating data back out or disrupting your environment from within. There's lots of tools out there. These are some open source tools that we mapped out to the kill chain just to kind of show what's available and what options are out there. There's plenty of commercial tools that operate at every layer here. And the challenge is these tools generate tons of data. It could be tens of gigabytes per day to even tens of terabytes per day, depending on the size of the organization, the amount of security tools you have in place, the IT telemetry data you pull in. As Rafi pointed out, you got a lot of data, a lot of visualization. It now becomes a problem of how do you find a blue needle in a stack of rainbow needles as quickly as possible. And very often, we're looking at the wrong thing, I think. So here's some examples of some of the data that we'll find. This is a small little segment. This is a browser user agent. So whenever you go to a website, your browser will leave a fingerprint behind. And this is one of the fingerprints that are left behind, in fact, 4. Only one of these is valid. 3 of these are fraudulent. So it's very easy to identify and spot these things, create rules to programmatically trigger on these, and if we're comfortable enough and accept the risk of friction to our end users, we can put in blocking actions, or we can start doing other things like perhaps slowing them down or routing them into a honeypot. And these are the problems with these user agent strings. So first one, we have MSIE, Internet Explorer, version 11, using the Trident Engine 5, just doesn't exist. Trident 5 was an earlier version of IE. That's a mismatch. This is often an error. And sometimes with criminals that we're dealing with, this is the only error we can catch to identify fraud or to identify malicious activity. Next one, NT 5.1, it's XP. XP doesn't support IE 11, so that one's been tampered with. And another challenge I have with a lot of tools, and one thing that really frustrates me, is a lot of the tools want to be helpful. They say, oh, we're going to insert Mozilla into this database or into this analytics platform, but we notice that the first letter is lowercase, so we're going to make that a capital. And sometimes that's the only signal we have, is one letter off, a lowercase instead of a capital. And we have to be very vigilant to find that type of data in there. And the bottom one is a legitimate Windows 10 IE 11. So as we look at breaches, we were thinking about this and how do we find this and how are these being missed? And one year we were working on metrics and we realized we have the same metrics that Target had. We have the same technology stack that Sony Pictures had. So why are we not in the news? And they are. So we started thinking about it. And often, like with the kill chain, that I believe came from a military background, we look at military examples and how did the military solve this? This is a B-17. They flew over Europe in World War II, dropping lots of bombs. The average crew successful completion of a tour over Europe was 25%. 1 in 4 completed, got to go home. These are bad numbers. They had lots of threats from the enemy and from above. Lots of problems. So the Army said, you know what, we should start taking a look at this and figure out how we can increase our survival rate. So they put a whole bunch of folks together, started looking at it. They analyzed the problem, they said, hey, these damaged areas, we can add hardening, we can add armor there, and increase our aircrew's survival rate. And so they had a plan, they started pushing it through, and one person came up with a problem. What we're looking at is the damage on planes that have returned. What we should be doing is looking at the undamaged areas. And that, if those areas are damaged, those planes get shot down. And that was Abraham Wald. He came up with analysis for aircraft frames and surviving planes. So he came up with this idea that we shouldn't look at where we're seeing damage, we should look at where we're not seeing damage and really focus in on those areas. And he came up with the idea that we should armor the areas that are undamaged and really focus in on those areas. And by doing that, doubled the survival rate of those air crews. The key point is the undamaged areas on the returning planes are where we should be adding it. So when we look at all these tools, we look at all this data, I see it as these are strong areas. We have firewall blocks, we have IDS catching stuff, we have AV catching stuff. Where are we not catching it? And flip the paradigm around. We should be armoring the areas that we don't have visibility in. So when we look at a typical enterprise security stack, Active Directory has tons of tools, monitoring, reporting. Usually Active Directory isn't the first target. It's usually an unloved server somewhere in a closet that someone forgot about. So one of the things that we've looked at with analytics and analysis is communication flows. If we have high communication flows and high stacks of security, chances are that's not going to be the first entry point into our network. It's probably going to be the system that no one logs into or has never logged into or logs into once a quarter, once a year. And those systems that aren't being used, hey, what if we add a lot more security to those? People are going to complain if you slow down Active Directory. They're going to complain if you slow down their email. But no one's going to complain about a HVAC server being slow in the utility closet. So what if we stack that up? And that was one of the interesting points that we came up with, and thank you.